We have finished the first chapter in OSPF. We learned a lot of information. The last information that we learned is periodic update every 30 minutes. Don't forget, many people don't know about this. OSPF will send the database every 30 minutes to all the neighbors to make sure they are fully synchronized. Now, other timers, like every 10 seconds, the hello packets are sent. That timer, if neighbor don't send the hello packet for 40 seconds, the neighbor will be removed by the 40th second. Linked advertisements are not hello packets, so don't get confused with hello packets and linked advertisements. Linked advertisements are sent only after forming neighbor. Hello packets are used to form neighbors. Fine, let us now get into this configuring OSPF packet types. There are 5 packet types. These numbers you see now, 1, 2, 3, 4, 5. This is not just a sequence number. This is not just a sequence number. OSPF type 4 means it is always link state update. OSPF packet type 4 means it is always link state update. Do we need to know this? Yes. If you are troubleshooting in the debugs, you will find this number. Not only that, when you capture using Wireshark, there also you will see. So if you know this number, it will be easy for you to filter the packet that you want to see. I repeat, in the Wireshark, when you capture packets, I'm going to do it and show you today. You will see hello packets, DBD packets, LSR, LSU, LSAC, all mixed in one page or many pages. But you wish to see only the update packets. If you know this number, it will be easy for you to see only those update packets. So we have to know these numbers. It's not simply serial numbers or sequence numbers. Okay, let us now go to the next one. In the IP header, when you capture the Wireshark, when you capture a packet using Wireshark, in the IP header you can see in the protocol field this number 89, IP 89. And the OSPF header will have these many fields. Version number, meaning what? Is it OSPF version or IP version? This is not an IP version, this is OSPF version. We are using version 2 for IPv4. Version 3 is for IPv6. What type of packet? If it is update, it will be 4. We just learn types. What is 4? Update packet. If it is hello packet, it will be 1. For hello packet, the type will be 1. And then the length of the packet in hexadecimal. And then the router ID we discussed in the previous class. Even we discussed this in CCNA. Every router will pick an IP address as a router ID from the loopback interface. If you don't have loopback interface, then it will take from the physical interface. When you have multiple address in the physical interface, it will take the highest, the biggest address, the big address, the big IP. But if you want to give a router ID manually, you can give, but it should be done while configuring the router. After OSPF process started, if you change the router ID, it won't get changed. You need to reboot the OSPF process. All these things we learn in CCNA, but I'll also remind you again and again when we do the lab also, I'll show you. Now the area ID. What area this packet is coming from? For the integrity, they do checksum value. If the checksum value is not correct, the receiving router will not receive the packet. Authentication type. OSPF supports 2 types of authentication. One is clear text authentication. The other one is MD5 authentication. MD5 authentication is called as type 2 authentication. Type 2 it will be here. For clear text, you will have 1 here. So null authentication. What is null authentication? You have not enabled authentication. And then the password itself. And then the data. Depending on the type, the data will vary. If it is hello packet, if it is type 1, which is called as hello packet, the data will be the hello packet information. Sorry. If it is type 2, then it is called DBD, database description. That is called LSDB. It will be bigger in size. The data will be too much. Type 3, LSR, link state request. When there is a query, the requests are sent. The requests are sent when the router feels that there is some incomplete information from the neighbor. Those requests are the data. LSU are the response to the LSR. LSU is nothing but link state update, which is type 4. And for all this, you will have type 5, which is called acknowledgement. Type 5 is acknowledgement. Can anyone say in this 5 type, which one is carrying LSDB? Which packet type here carries LSDB? See, number 4 is a response to a request. But number 2 is the one which is LSDB, link state database. I told you, I remember that. I told you. When the router shares LSDB, they don't share complete information. They share only the summary. So that the receiving router will manage to understand the complete database. That will reduce the amount of bandwidth used by this advertisement. So this packet type 2, we don't call it as LSDB packet, we call it as DBD. DBD, database description. Database descriptions or LSDB. Database descriptions or summary of LSDB. Yeah, see, you went to some country, and when someone asks you how was the country, you stayed there for 10 days. Now, will you tell the experience for 10 days? No. You will try to finish in 10 minutes. So, you stayed in Switzerland for 10 days, but when I ask you what was your experience in Switzerland, you finish in 10 minutes. Why you are not saying that for 10 days? Because you know that I will understand what you say. You know that I will understand your experience of 10 day in 10 minutes. போனேனா இறங்குனேனா பஸ் ஏறினேனா போயினே இருந்துச்சு. இப்போ வந்துடும் பார்த்தா நிக்கவே இல்லை. நைட்டு போய் சேர்ந்துச்சு. அப்புறமா ஒரு ட்ரெயின் பிடிச்சேன்னா, அப்புறமா ஒரு ட்ரான்வே பிடிச்சேன்னா, அப்புறம் ஸ்டேஷன் விட்டு இறங்கினா லெஃப்ட் சைட்ல இருந்துச்சு ஹோட்டல், எனக்கு புக் பண்ண ஹோட்டல். நெக்ஸ்ட் டே மார்னிங்கா ரிசப்ஷன்ல ஒரு கவர் கொடுத்தாங்களா, அந்த நாட்டு காசு கொடுத்தாங்களா, வாங்கினேன்னா ட்ரெயின் ஏறினேன்னா, அப்புறம் ஒரு ட்ரெயின் பிடிச்சேன்னா, அப்புறம் இன்னொரு ட்ரெயின் ஏறினேன்னா ஆஃபீஸ் வந்துடுச்சு. இப்படி 10 நாள் போயிடுச்சு. சாப்பாடு என்ன, பீஸா தான். வேற என்ன நம்ம நாட்டு சாப்பாடு கிடைக்கும்? ஒரே பீஸா தான், எப்போ பார்த்தாலும் பீஸா தான். அவ்வளோதான், திருப்பி வந்துட்டேன். See how simple it is. 10 day story in less than 2 minutes. You understood. Likewise, OSPF also sends the DBD in a short and sweet method, summarized manner. That LSDB is called as DBD, database description, which is type 2 packet. In that type 2, if there is need for some clarification, உங்களை மாதிரி இப்போ நீங்க கேட்க வரீங்கல்ல, சுவிட்சர்லாண்ட்ல வேற என்ன இருந்துச்சு, சுவிஸ் பேங்க் இருந்துச்சா, சுவிஸ் பேங்க் பாத்தீங்களா கேக்குறீங்கல்ல, அந்த மாதிரி அதான் LSR. That is type 3, link state request, because you want to clarify that one doubt. எவனை பார்த்தாலும் சுவிஸ் பேங்க்ல பணம் வச்சிருக்கிறான்னு சொல்றானே, சுவிட்சர்லாண்ட்ல போய் அதை பார்க்காம வந்தா எப்படி? Then I am saying I was teaching in the same street where Swiss Bank is. In fact, the organization to whom I was delivering the training is a financial advisor company for Swiss Bank. See, that's a update. You asked me a query called LSR. I gave you a response called LSU. But that LSR is dependent on what you received in DBD. In that DBD, you have some doubts, so you want to clarify a detailed information for particular link state, maybe. That's LSR. Now I was talking about type 1 hello packet. You see what all hello packets carry. So lot of things are there shared in hello packets, but only few things must match to form neighbor. Every router sends hello packet. Each router will have unique router ID, so definitely it should not match. The router IDs helps to identify the router. நான் சொன்னேன் இல்லையா என் கிளாஸ்ல 2 பசங்க இருந்தாங்க ஒரே மாதிரி இருப்பானுங்க ஒருத்தன் என் ஃப்ரெண்டு இன்னொருத்தன் எனக்கு எனிமி ஒருத்தன் பேர் ராமன் இன்னொருத்தன் பேர் லக்ஷ்மண் நம்ம எனிமி கிட்ட பேசிட்டு இருக்கிறோமா நண்பர்கிட்ட பேசிட்டு இருக்கோமானே தெரியாத அளவு இருப்பானுங்க 2 பேரும் ஒரே மாதிரி இருப்பானுங்க அப்படி இருந்தாலே குழப்பம் தானே likewise two routers cannot have same router ID that will cause confusion each router should have a unique router ID only then they can form neighbor. Timer also should match. What is the timer? For 10 seconds and 40 seconds. Neighbor list. My neighbors will be different. His neighbor will be different. Definitely that will not be matching. Even neighbor list is shared. That is what you need to know. In the hello packet, even the neighbor list is advertised. நம்ம தான் பார்த்துருக்கோம் நிறைய பேர் இன்ட்ரடியூஸ் பண்ண மாதிரி சொல்லுவாங்க நான் வந்து இன்னாருங்க எனக்கு இன்னாரெல்லாம் தெரியுங்க அப்படின்னு சொல்லுவாங்க அப்ப இவன் வெயிட்டேஜ் கூடும் இந்த காமன் ஃப்ரெண்டுலாம் சொல்லுவாங்கல்ல ஃபேஸ்புக்ல லிங்க்டின்ல எல்லாம் அப்போ வந்து இன்னும் கொஞ்சம் பாண்டேஜ் சீக்கிரமா உண்டு பண்ணும் நம்பலாம். Likewise, OSPF also sends the neighbor list in the hello packet. For example, when A send a hello, in that hello, A's neighbor, let's say B and C are neighbor. A will say hello to a multicast address only. It is not saying to DRE. It is simply saying to multicast address 224005, which is received by E. Now, when E receives the hello from A, in that hello, A says, I'm A, my router ID is this, I'm A, and my neighbor is B and C. The neighbor's IP address will be there. Neighbor's router ID. Okay. Next is area ID. Area ID must match to form neighbor. Right from the beginning, I'm telling this. Router priority by default in LAN, priority is 1. What is the priority for WAN interface by default? Can anyone say? I repeat, for LAN, the default priority is 1. The maximum priority is, what is the maximum priority number you can set? 255. Now, my question is, in WAN, in serial link, what is the default priority? சொன்னாதானே தெரியும் நான் சொல்லவே இல்லையே. The default priority is 0. Okay, the default priority on the serial link is 0. Why you know 0? Because it is not needed. What is not needed? There is no DR-BDR election. When a router has got high priority, that becomes DR. But in a point-to-point, why there is need for a DR? Why there is need for a BDR? It's just two routers. You give me, I give you, we are synchronized. Finish. But in a LAN network, there are many routers. So we choose one We means OSPF picks one DR based on the priority. In a WAN link, there is no DR BDR election, so there is no need for priority. That's why the default priority is 0. If you want to go and set some priority, you set, but it is of no use. If you set 100 here priority, what is the use? Where it is going to be used? Nowhere. Will it allow me to change the priority from 0 to something? Yes, it will allow you, but it won't be useful. In a serial link, it won't be useful. So don't waste your time setting priorities. I want to repeat this again. You see, when you have more than 2 routers connected like this through Ethernet, through LAN, we call it as LAN. Here we need DR and BDR. You may ask why. Don't worry, I'll explain you why. But here there is no need actually. Only between these 2 routers. You give me, I also give you, we are synchronized. But here, you need a DR, you need a BDR. Why? To avoid duplication, to avoid the duplication, meaning to avoid loop. When same update has been given by many repeatedly, it becomes a loop. You see, here only 2, there is no loop possible. But here, let's say D is giving one update to all. Everyone receives that update. Now, when E also takes that update it received from D, and if it sends that, what will happen? Duplication. If everyone is talking to everyone, then there will be duplication. To avoid that everyone talking to everyone, what do we have? DR. If this is DR and BDR, I told you these 2 guys and these 2 guys will be simply neighbor only. They won't form adjacency. They won't give anything. They will give only to the DRs. The full adjacency is only with DR. Full adjacency only with DR. When you do like that, what happens? B is not giving to A and C. B only gives to DR, and DR will distribute it to A and C. Problem solved. Can A and C talk? No. So A cannot send that same copy to C now. If A wants to send something, it can only send to D. B, A, C, they are not authorized to talk each other. If they want to say something, they should send through D only. That prevents loop. If no DR, BDR, then all will give to all. There are chances of same update given by many, which will cause loop. Did you understand why we need DR, BDR in OSPF? Please ask question. Right? So this DR, BDR is important. That prevents everyone talking each other, which may cause duplication of same info from different sources. Only when there is DR, BDR, priority is needed. That's why on serial wires, the priorities are set to 0. Next, if a router knows some informations like DR, BDR, it will also send who is DR, who is BDR in the hello packet. I told you hello packets are not only to form neighbor. Even after forming neighbor, In a multi-access environment, the priority is 1. If you increase the priority of a router, that router becomes DR. Other than that, these informations also shared like DR, BDR addresses. After forming neighbor, also the hellos are sent. In that hello, even these informations will be sent. In the initial days, sorry, in the initial minute in the beginning, when the election process is still not over, this field will be 0000. But once the DRBDR is elected, the IP address of DRBDR will be also sent in the hello packet. And authentication, if enabled, that also will be sent. Stub, if enabled, that stub flag will also be sent. We'll talk about stub later. So these are the infos a hello packet carries, in which parameters like hello timer, area ID must match. If authentication enabled, that also should match. If stub is enabled, that also should match. Otherwise, they don't form neighbor. Right. Now, what we are going to see is how the adjacency is formed. What do you see? Do you see a serial 0 or Ethernet 0 there? Ethernet, which means there will be a DR-BDR election. Even though there is only 2 router, one is going to be DR, another is going to be BDR, because this is not a serial wire. Only in serial wire, it is considered as point to point, there is no DR-BDR. But in an Ethernet environment, whether you have third router or not, even if you have just 2 router, there will be one DR and one BDR. Okay. Initially, these 2 routers are still under configuration. Still, it is getting configured. So, it's in down state. One of the router finished configuration, like router A, you finish the configuration. So A is sending the first hello packet. It is saying, hey, I am router so and so. I don't have any neighbor yet. I'm just a newborn router. I don't have any neighbor. I told you, no, the hello packet neighbor address will go. This third one. It says I don't see any neighbor because this is the first time I'm saying hello. No one has told hello. This we call it as initialization state or init state. What you are learning is common. It's an industry standard protocol, whether it is Juniper or Cisco or any other vendor. This is the stories same. These stories that you learn in OSPF or same. Init state. And now what happens? B receiving the hello packet. B learns that I got a neighbor called A. So B puts A's address, this is the address of it, and sends the hello packet to A saying, I am this and I know my neighbor so and so. See, after learning neighbor, what it does? Unicast. Before learning neighbor, it was sending multicast. Now, don't think it will not send multicast hellos again. Only this time it is sending unicast. Once the neighbor is fully adjacent, it will start sending hellos only to multicast address. Only to 224, not 244. 24. எப்படி எழுதிருக்காங்க நமக்கே தெரிய சவுண்ட் சந்தேகம் வர மாதிரி எழுதிருக்காங்க 224,005. See, B already knows A. Now A also knows B. This forms two-way state. Down state, init state, two-way state. It was down initially. Then one of the routers sent the very first hello, which is initiating the adjacency, initiating the neighborship. And then the other guy also sends hello to this one. That makes this one to know the other guy. This forms two-way state. I know B, B knows A. After two-way state, they want to exchange what? They want to exchange the DBD, which is the summary of LSDB. But to do the exchange, they need to decide who will initiate this exchange. Who will start the exchange? So, before exchanging, they do a discussion. See, I am going to send you the DBD. Who is saying? A is saying. B says, see, this is not fair. I have a bigger router ID. I have the higher router ID. So I only will start exchanging it. Then what A will say? Yes, you are right. I'm sorry. You are right. You are first, please. You start exchanging. So immediately B starts exchanging, followed by A also exchanges. But they are not exchanging the complete LSDB. Again, I'm telling you, it's complete, but not a detailed one. It's a summary one. See, first it was down state. After down state is init state. After init state is two-way state. After two-way state, it is X-start state. Why it is called as X-start? Exchange to start, they need to conclude who will start. That discussion is going on. The one with the bigger router ID only can start the exchange. That they decide here in the X-start state. Afterwards, now they know who should start and who should only listen. In this example, B is starting the exchange, A is listening. Afterwards, A is exchanging, B is listening. After exchange, they have some queries. Okay, acknowledgement will be sent by both, saying I received your DBD. And now they go to loading state. What is loading state? They will start querying each other. See, I need more information on this particular link state. Can you give? That is what LSR. Because the DBD is not detailed on no, so it has got queries. And this router says, yeah, here is the update. Take it, the complete information. After a point of time, this both the routers are fully synchronized. There is nothing more to query. Whatever this router knows, that router also knows. So fully synchronized. We call it as full state. Full state. In a point-to-point network, both the routers will reach full adjacency. What does that mean? It goes through all this 7 stages. 3, 4, 5, 6, 7. 7 stages. But in a LAN environment, only with the DR BDR they will go through full state, but between the DR other, they will be in two-way state. They won't form full adjacency, they will go only up to two-way state. Two-way means what? Two-way means what? I know you, you know me. That's all. That know me meaning what? I know your name. You know my name. That's all. Not more than that. I just know your name. You know my name. That is called two-way state. What is full state? Beyond that, they exchange all the info each other. That's full state. All right. So 7 stages. Don't forget. Down state, init state, two-way state. Init state is one of the router is sending the first hello. Two-way is the other router also sends hello. Now both know each other. That is two-way. Start state is the place where they decide who will start the exchange. They compare the router ID and one will say, I have the biggest router ID, highest router ID, so let me start exchange. The other one will agree. That is start state. Once they agree, they start exchanging the summary of LSDB called DBD. After the exchange of DBD, if there is a query, they go to loading state where they send LSR asking more detailed information for some prefixes. Once the synchronization is done, they attain full state by sending acknowledgement. Anyone has got any question? Hmm. 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 அது அடுத்த பேஜ் வருது, அது அப்புறம் பார்க்கலாம். Very, very important. Very important. In the hello packet, the subnet also should match. Here they have not mentioned. The subnet should match to form neighbor. Very important. Okay. Any other question? All right. Now let us see what our Sangeeta ma'am is telling. You see, here we have 4 routers. There is a link behind A gone down. Now A is not DR or BDR. A is DR other. Sorry. A is DR other. Let's say this is DR. And one router BDR also I want to keep BDR. See, as soon as they become DR and BDR, they join one group. To receive update, they will be listening to 224.006. They will be listening to this address. And to send, they will use 224.0.0.5. Whereas the other routers know that is opposite. To receive, they will be listening to 224.0.0.5. To send update, they will use 224.0.0.6. So all the other routers, if they want to send update, they can use only this address. Now, who is listening to this address? Only DRs. No one else can receive it because only DRs listen to that address. And now when DR wants to forward it to others, it will use this address to send, and all others are listening to that address. This is how, without confusion, the notification goes. In short, read the two line at the bottom. In the place of router A, put DR other. DR other notifies to OSPF DR on 224.0.0.6. And DR notifies to other, meaning DR others, using 224.0.0.5. Is that clear? Any question from anyone? கட்டாய receiver. Because it is sending to a multicast address, A will also receive a copy, but A will ignore it. Why? It has got a router ID of A in that. Whose update DR is sending? A's update it is sending. When a router receives an update, first thing it will check from where it is coming. If it finds its own packet or its own router ID in that packet, it will ignore. No. Only for updates. Hellos are sent to 224.0.0.5 only. Hellos are sent to 224.0.0.5. That's a very good question. For hello, it is exception. Any other question? All right. If no question, we'll stop here. We'll continue this